So let's look at the first one. So this was a question 3. We're still doing the KZN 2020 prelim paper that they wrote in September. And we are told that a ball is thrown. This is one of the key words in physics. In physical sciences, if I throw you with something or I push you to a certain direction, I actually have initial velocity and that object moves with initial velocity. But if this falls or this slips from my hand or this is released from my hand, then it means that gravity was doing most of the work. It does not have an initial velocity. If you applied a force, then it has initial velocity. So now we know that it was thrown vertically upwards. Vertically up means going up from the top of a building. Now, there's another one, building. Remember, buildings do have heights, my darlings. With an initial velocity of 12, the ball leaves the thrower's hands at a point that is 50 meters above the ground. The ball just misses the edge of the roof on its way down and bounces off the ground. This is the image that we have. So now from the ground as 0 reference all the way here. So now this is 50 where this arrow is. We do not know how high this is. So if we had to find the total height, it would be 50 and whatever this x position would be. I know that it was released with an initial velocity of 12. I love writing on the question paper. I love writing everything I'm given so that I see it. I know that if I throw an object up at maximum height, the final velocity is 0 meters per second. We do not see it, but in a split second, it kind of stands still and then it comes back down when gravity says come down. Now I also know that time going up, I'm just going to write a t is equal to time coming down. However, when it gets to this part, it misses the thrower's hand and then it comes down to the ground. So that's all the information that we have. Now 3.1.1 says we must calculate the time taken for the ball to reach maximum height when it is thrown. Right? Now I know I've got final velocity, I've got initial velocity, I'm looking for the time, and I know that gravity will always be 9.8. Now with questions like this, I would also advise you to always choose a direction. You can choose it on your picture or whatever really makes it easier for you. But we're doing 3.1, I just want to number it accordingly, 3.1.1, time taken. On your formula sheet, I've just checked, I'm going to choose this formula. I'm going to say VF is equal to VI plus A delta T. Now, before I continue with this question, I want to elaborate on something. I would always advise you to find a formula that does not require you to calculate something, take that answer, plug it in somewhere else, and then take that answer and then plug it in somewhere else. Because when you keep moving around like that, if it's unnecessary, then you do make mistakes, right? Always find a formula that is simple, straight to the point, and then you can just plug in everything and then get your answer. So I just chose this formula because I have my final velocity at 0 at maximum height. Initial velocity, it was released at 12. Gravitational acceleration is 9.8, and I'm looking for t. Indicate to the examiner what direction you're taking. I love taking up as a negative and down as a positive. Remember, gravity for me, gravity always pulls everything down, so that is why it's a positive. Remember, it's important to choose direction for the examiner because once you get an answer, you must give direction. Why do we give direction? Remember, in grade 10, we learned that velocity is a vector quantity. It has magnitude and it has direction. So you're giving direction to the direction of the ball, whether it's moving up or coming down and so forth is very crucial in such questions. So let's plug in. My VF is 0. Initial velocity, the ball was thrown up with an initial velocity. This is minus 12 plus. Gravitational acceleration is 9.8. And that is then delta t. I'm going to move the 12 to the other side. Remember, if a number moves to the other side of the equation sign, the sign will change. If it's a negative on this side, if it moves to this side, it becomes a positive. I'm going to have 9.8 delta t. I want delta t by itself. I'm going to divide both sides with what is bothering the delta t. 9.8 divided by 9.8 is 1, and 1 times delta t will remain delta t. Let's calculate this one. So that is 12 divided by 9.8. And then I get 1.22. So now because I'm going to write it wrong and then I'm going to write it right, and I'm going to tell you why. So that's 12244. 1.224. Let me leave it to 2 decimal places. And I'm going to just say 1 is 1.22. The SI unit for time is seconds. Why did I do this? Remember, in vertical projectile motion questions, you're going to use the time and plugging it somewhere else and move that time and plugging it. So you are constantly rounding off your answer, which actually moves your answer more and more towards away from the correct answer. What's nice about such questions is that whoever's going to be marking, the memorandum will actually have a range to say, we'll mark 1.22 to 1 point this, and stuff like that. But it's always nice to write the time like this, moving on if you need the same time, leave it to 2 to 3 or 4 decimal places and then plug it in. It just makes it easier for the examiner. It actually makes your answer a little bit more accurate. So that is then the time taken to reach the maximum height for the ball. Let's look at our next question. So 3.1.2 says, the maximum height reached by the ball above the ground when it is thrown. Now listen to the question. It's for 4 marks. Above the ground when it is then thrown. What are they telling us? We know that it didn't start from the ground. It started from 50, but the ground, from away from the ground is another 50. So whatever your height is going to be here, let me change this to a h. Whatever your height is going to be here, you are going to add that h to the 50 because they said ground. If the question had said, calculate the maximum height that the ball reaches from leaving the thrower's hand, then you can just calculate from the thrower's hand to maximum height and calculate the distance. But the question said the maximum height from the ground. English. So we're using the ground as a frame of reference, moving all the way up. So let's calculate that. So do not forget to add all of the other stuff for the examiner. Let me use a clean slate because I'm going to show you various ways on how you can do it. So this will be 3.1.2. So the first one, the first formula, this you get on your formula sheet again, I would take is this one plus 2a delta y. Remember, I'm looking for my y. My final velocity, they threw it up at maximum height. The final velocity is 0. My initial velocity is 12, negative 12 squared. Why am I taking negative 12? I love taking up as a negative and I take down as a positive because gravity for me is always coming down. But you can do it vice versa. Plus, this is a 2. A is my gravitational acceleration, which is 9.8, and I'm looking for delta y. Now this I can do in my head. 12 squared is 144. Okay, let me do it the long way around, just in case somebody is getting confused. This is 144. Remember, a negative times a negative is a positive, and 12 times 12 is 144, plus 2 times 9.8 that I can do in my head. That is 19.6, and that is then delta y. I want delta y by itself. I'm going to move the 144 on the other side of the equation sign. It is a positive on this side. Moving it over the equation sign makes it a negative 144, and that will equal 19.6 delta y. I want my delta y by itself. I divide both sides with the number that is bothering my delta y, which is 19.6. 19.6 divided by 19.6 will be 1, and 1 times delta y remains delta y. Do that one. So I'm going to have negative 144 divided by 19.6. So here I've got 7.34. Remember, the 6 is if it's a number 5 or greater, it'll change the number before it to the next number. So I'm going to have 7.35. Remember, a negative just means direction. Remember, it is up. So my negative just means my direction. So it's negative 7.35. I want to write it again. I remove the negative as 7.35, but they did say from the ground. So delta y, remember we use delta y because it's moving up. If it was delta x, it would have been moving horizontally. Delta y total, I would say, remember it was already in a building that is 50 meters up. From the thrower's hand, the thrower was able to throw it another 7.35 meters into the air. And this we can do in our head. This will be 57.35 meters. The SI unit for distance is meters. Remember, distance must always have a small m right afterwards. So this is the one way you could have done it. Another way you could have tackled this problem is you could have done it like this. You could have said delta y, and you could have used this formula. I've got VI, I know that that's 12, plus VF all over 2, and that is then delta T. Remember, you also get this in your formula sheet. Why would I have used this one? I'm already looking for Y. I know that my initial velocity, it is thrown up by negative 12. At the final velocity at maximum height is 0, all over 2. And the time taken to reach maximum height, let's go back to our previous question. They said the time taken to reach maximum height, that's the time taken. I'm going to use this one. Remember, I would rather have you take it to 2 to 3 or 4 decimal places just for more accuracy. So using the previous time. Now, if you did by accident get that time incorrect, then it's okay. You'll get continuous assessment, 2 to 4. I'm going to do it the long way around. Negative 12 plus 1 will give me a negative 12. Divided by 2 will give me a negative 6. Multiplied by 1, 2 to 4. Calculate that one quickly. Remember, the negative just means direction, so I can say negative 6, 1.224. And there we have that. Just change that again. 1334. So that will be 7.34. Remember, they said from the ground. So I'm going to say delta Y total because the ground was used as a frame of reference. The building was already 50 meters high, and the thrower threw it another 7.34 meters in the air, and that will give you 57. That will give you 57.34 meters. That is another way you could have done it. The last way I will show you, I'm going to say another or here. Hopefully, yeah, let me just write here. You could have used delta Y. I'm not going to write the whole thing, just so that we can actually finish another question. But delta Y, delta T, plus a half, acceleration, and T squared. Remember, I'm looking for my Y. Just want to move this. I threw it up at 12. The time taken to reach maximum height, plus a half, acceleration is 9.8, and then my time squared. And then again, you should get delta Y as 7.35 meters. Using the ground as reference, then you'll add the 50 to this. So as you can see, you get the same answer every time. The important thing was to know which formula to use. And as you can see with all my formulas, I've tried not to find something and then substitute it there and then find this in order to find something. You must find a formula that accommodates everything that you're given. Going back to why I like putting all my information on a picture. If you're already reading your scenario and you're already plugging in everything that you've given, once you're looking at this person throwing something up, you already see the initial velocity. You are seeing the final velocity. You already have the time to take to reach maximum height. It just makes it easier when you're choosing a formula. It's a bit tricky or a bit dangerous to use a formula that has a lot of unknowns, so rather fall into something that you know you're a little bit more comfortable in. So that is then how we'll calculate the maximum height reached from the ground. Let's look at another question. Now they're telling us for 3 marks, we must calculate or determine the velocity of the ball at a time of 4 seconds. Now this must not confuse you at all, right? This means we threw the ball and somebody was counting somewhere. We throw it up, it goes 1, 2, 3, 4. Now, at that point, when the time was 4 seconds, we must then determine the velocity. So you already have your velocity and you have all your other things. They just given you the time. So it's just as simple as that. So let's calculate that one. So that will be, this will be 3.1.3. And then again, I'm going to show you various ways on how you could have went about it. So the first one, you could have used this one. Remember, you also get this from your formula sheet, A delta T, but it's also very nice to know your formulas off by heart. It just saves you time. Remember, if something is thrown up, you must always choose velocity. I like taking negative as up as a negative and coming down as a positive. You can do it vice versa. Remember, up and down just means direction. My initial velocity, it was thrown at an initial velocity of 12 plus. A is my gravitational acceleration, which is 9.8. My time, they said at a time of 4 seconds. So where there's T, I just substitute that with a 4. I'm going to put all this exactly as it is in my formula, in my calculator. plus, and I'm going to have 9.8 multiplied by 4. And then I get 27.2. I get 27.2 meters per second to exponent 1, the SI unit for velocity. My answer is a positive. A positive is going downwards. Remember, velocity is a vector quantity. So you could have done it like that. Another way you could have done it, I'm going to say or on this side, a little bit complicated, but just so that if you were thinking along this way, you could have said delta y. I do have my initial velocity. I'm given my time plus 1 over 2 a delta t squared. Remember, they want the final velocity. If I'm able to calculate how high the ball was at 4 seconds, I just want to go back to this drawing so that I actually make it a little bit more clearer for you if you were thinking along this way. Because we obviously, as people, we think differently. If 4 seconds was there, if the time was there, which was 4 seconds, if I can calculate how high the 4 seconds was there, I can also calculate the VF at that point. So this is my line of thinking here. So I'm going to find how high it was at 4 seconds and then use that height to calculate my VF. So therefore, I can say my initial velocity was negative 12 because up is a positive, is a negative. My time was 4 plus I've got 1 over 2. Gravitational acceleration is 9.8. They told me that my time is at a time of 4 seconds, and that is 4 seconds squared. I'm going to put everything as it is in my calculator. Remember to always put brackets around your things. It just makes it easier, and if you don't, your calculator sometimes just tends to do BODMAS. So that is 0.5. I'm going to have 9.8. Close my bracket, and I'm going to have 4 to the exponent 2. And therefore, I get 30.4. So at a time of 4 seconds, the ball was 30.4 meters above the ground. Now that I've got the height, I can therefore find the velocity. I therefore can substitute this in this formula. So say delta y is equal to VI plus VF all over 2 multiplied by delta t. My delta y at 4 seconds, I know that it is 30.4. My initial velocity, the ball was thrown at the initial velocity of 12, but because I've chosen up as a negative, it's a negative 12, plus I'm therefore looking for my final velocity. This is all over 2. My time, I am told, it is at a time of 4 seconds. Now this is just pure mathematics. I'm going to do it the long way around. Remember, this is a multiplication. I just want to write it in a simpler way. So technically, it looks like this. VF, I'm going to multiply 4. I'm going to multiply 4 with 12. And then I'm going to multiply 4 with VF. So I'm going to say 30.4. If I say 12 times 4, that will give me negative 48. Plus 4 times VF will give me 4 VF. All over 2. Now, more mathematics. Now, remember, I have to then cross multiply. All of this multiplied by 1 remains itself, which will give me negative 48 on this side, plus 4VF equal 30.4 times 2. 30 times 2 will give me 60. 4 times 2 will give me 8. So that should be 60.8. Now I need to get VF by itself. I'm going to take this number. It's going to go on the other side of the equation sign. I want to have like terms by themselves. Remember, if this is a negative 48, if it comes to the other side of the equation sign, it becomes a positive. I therefore have 4VF. I'm going to do it the long way around, 60.8. I'm going to plus 48. I'm going to have 4VF. Let's add that. That I can't do in my head. So I'm going to have 60.8 plus 48. I'm going to have 108.8. Now I want to have VF as my final velocity by itself. I have to divide both sides with the number that is bothering the VF, which is the 4. I'm going to have VF. Now let's divide that and see what we get here. I must divide that by 4. And then I get 27 27.2. 0.2, the SI unit for velocity is then meters per second to the exponent 1. Remember, velocity is a vector quantity. I've taken positive I've taken downwards as positive. My answer is a positive, therefore magnitude and direction 27.2 meters per second downwards. Downwards. Now I just want us to go back here. As you can see, it's two different ways of doing things. I got exactly the same answer here. If you were thinking on the lines of, I want to first know the distance and then want to know the velocity at that distance, then you could have done this whole long method. But technically, it's exactly the same thing. Let me see if it was actually worth the mark to go through all that effort. Well, it was for 4 marks. No, it was for 3 marks. Okay, so it wasn't that bad. So I would have taken it. Now, the next question says, 3.1.4 says the position, right? Now, we want to know how high was that ball at the time of 4 seconds. Now, if you had done this method already, you would have already found out how high the ball was. But if you had found this method, you wouldn't know how high the ball is. So let's then calculate that. So this will be 3.1.4. The position means height. Remember, position times graph usually tells us the distance. So from your formula sheet, I just want to choose direction again. Negative as a going up and a positive coming down. From your formula sheet, you could have used this formula, delta y is equal to VI delta t plus 1 over 2a delta t squared. So with this formula, I just want to elaborate on something as well. As you can see, it's more or less like then that one. So I'm just going to plug it in. Now remember, even though you have done it, I would always say go again and redo it so the examiner can see that you know exactly what is going on. At the time of 4 seconds squared, we calculated that in the previous one, and we found that the position there at that time was 30.40 meters, and that is then how we calculate height. However, remember, from the ground, if the ground is 50 and we throw it up another 30.40 meters in the air, how high was it then from the thrower's hand? They said the position from the thrower's hand, it is 50 minus 30.4. So technically, it was at 19.6. 19.6, and then we have meters per second there. Now, I just want to quickly do this one. And then we were told for the last one that we need to draw a graph. So on hitting the ground, when hitting the ground, the ball bounces vertically upwards with an initial velocity of 25. We must draw a velocity versus time graph, sketch the graph of the motion from the time it was thrown vertically upwards to the time it reaches its maximum height. Use the ground as a reference point. The following we need to indicate: the initial velocity of the ball when it is thrown, the time taken to reach maximum height when it is thrown vertically upwards, and the initial velocity of the ball after the first bounce. So let's just quickly do this one. So this will be 3.2. If you had to draw your graph, I'm only going to draw the one. You had to the second bounce, you had to show the initial velocity which was thrown, the time taken to reach its maximum height. So it was thrown by 12, reached maximum height, bounced in the air, and then it bounced up with a velocity of 25. That will be a velocity time graph. Remember to name your vertical, your horizontal, and always give it a heading. And use a ruler.